With Chapter 12, we're looking at the gas laws. Now, things like a balloon, they have different variables that are involved on here. Now, some of the variables are very straightforward. Volume, we know we could do volume, we would do that in liters or milliliters. Temperature, we know about that, we would do degrees Celsius or kelvins. Number of moles is going to be involved, and that's obviously in moles. But as pressure is the one that we're probably a little less familiar with, so that's the one we're going to study right here. We want to look at air pressure and what that means, what units we use for different pressures, and finally be able to convert from one pressure unit to another. Now we live down here in the bottom of an ocean of air. So we live, down here, and so we feel the pressure of all these air particles above us. If we were to go up into a higher altitude, we would be above a lot of the air, so the pressure would feel less, the higher we go. So living down here, we'd feel a large pressure, and if we lived higher up, we'd feel a smaller pressure and smaller pressure as we go up. Now, back from physics, you probably learned that pressure is equal to force per unit area. Now, the force is, force downward, that's weight. So if we had a big book, and these are not actually books, these are actually banks, but they look good. With these books, they have a certain force because of their weight. So we say there's a certain number of pounds that they're pushing down. So let's say that we laid this on your stomach, then you'd say, well, I feel a certain number of pounds, but it's spread out over this much area for this book. So when I took the pounds and divide by the area, let's say in square inches, then that would give me the pressure of the book. Now, if instead of having the book flat like this, if I were to take the book and stand it up on its end, then the force would be the same. I get the exact same force because it has the same weight, but the area would be smaller. So the force divided by a smaller area, then that would give me a greater pressure. So both of these books would exert the same force, but since it's over a different area, I would get a different pressure in both cases. Now, kind of an extreme example, here we have a bed of nails. So these are all sharp little nails sticking up. And of course, if you were to press a balloon onto a single nail, then it would obviously pop the balloon. But what we have here is over a lot of nails. So in this case here, we have a certain amount of force to push down over a large area. Okay, so therefore we get a small pressure, small enough so that this balloon hasn't popped yet. I thought this was a really interesting looking picture. Now, as the numbers we're going to be using for this is the pressure that is exerted by the air. Okay, so like 1 atmosphere's worth of air at sea level, we just call that 1 atm, 1 atmosphere's worth of pressure. If that same amount of pressure, if we look at it in terms of pounds per square inch, it turns out to be about 14.7 pounds per square inch. Now 14.7, that is, let's say, the weight of a relatively small dog. And that small dog, if we could get it to stand up on 1 foot, then that would be about 1 square inch. And so that 1 square inch of pressure, that 1 square inch of area with a force of, let's say, a 14.7 pound dog, that would be a pressure that is exerted on us. And that's the same as the pressure of, 1 atmosphere's worth of air. Now, in the metric system, we have exactly the same idea, okay, but we use different units. So instead of pounds, the force for metric system is done in newtons. And a newton is about the mass, or about the weight exerted by a small apple. And that's what this little picture here is kind of trying to show. So if you could imagine one small apple pushing down, that's 1 newton. And we have the area that we use in metric system is a square meter. So that's quite a bit bigger than a square inch. So in this case here, if we were to take our apple and say turn it into applesauce and spread it out over our entire square meter, then let's say you laid that on your hand, laid that on your stomach, it would not exert a very big pressure. Okay, so that small force over that big area, that would be a pretty small, but we call that in metric units a Pascal. Now, a much more useful formula then would be if we had 1,000 apples. So we put 1,000 apples pushing down on that square meter, then we would call that a kilopascal. And that's the unit that we use for metric system. And even in that situation, a kilopascal, to have the same pressure as 1 atmosphere, it takes 101.3 kilopascals to equal the pressure of 1 atmosphere, or 14.7 pounds per square inch. Now, let's say we were looking at water, and we wanted to drink some water, and we're going to drink it through our straw. And when we drink water through a straw, we always think we're just kind of like sucking the water up through the straw. But in reality, the air is pushing the water up the straw. So when we are drinking out of the straw, there is air in the straw, and the air is pushing downwards, and the air on the outside is pushing downwards. So when we are drawing on the straw, what happens is we're removing some of these little particles, and so the air on the outside is able to push the liquid up through the straw. So when we're drinking, it's because the air is pushing on the outside. Now, let's say instead of this kind of air, we wanted to see, well, how high could we drink with our straw? It turns out that if we tried and tried and tried, we'd be able to get about 33 feet tall. We could drink this glass of water if we had a really long straw, about 33 feet up in the air. And the reason is that a 33-foot column of water has the same weight as a column of air all the way to the edge of the atmosphere. So the air can only push enough to hold up a column of water 33 feet. So that would make a good pressure measurement. From day to day, we could find out how many feet of water that is. It's inconvenient because, a 33-foot column of water, that's going to be hard to measure. Now, if we use instead something like mercury, now mercury is about 13.6 times more dense than water, so the column would only have to be 13.6 times the size. So 33 feet divided by 13.6, we're going to get an answer somewhere around 3 feet, a little less than 3 feet. So the idea here is if you were to take a big glass tube and you could totally fill it up with mercury, okay, put your finger over it carefully, and then invert it into a dish of mercury, then the mercury column would automatically stop. It would stop at about 760 millimeters. So we say that the air pressure is 760 millimeters of mercury at sea level on a normal day. And up above here, we would actually have a vacuum. And this is one of the first ways that they actually made vacuums, was to get a tube that was longer than 760 millimeters and fill it totally with mercury. When you inverted it, whatever was left up here at the top would be a vacuum. Now that comes to our modern day barometer. So modern day barometer is just a tube that has to be longer than 760, and the air is pushing down on the surface of the mercury. And from day to day, if the air pressure happens to be higher, like on a nice sunny day, then the column of mercury would be greater than 760. On a day that looks kind of gloomy, where the pressure is lower, then it would be lower than 760. But 760 millimeters is the same pressure as 1 atmosphere, it's the same pressure as 14.7 pounds per square inch, and it's the same pressure as 101.3 kilopascals. Now, in the weather, once in a while you hear about inches of mercury is the way they usually talk about it. So say the pressure today is 29.5, and they're talking about inches of mercury. But for us, we always do things in millimeters of mercury. Now, there was a guy named Evangelista Torricelli, and he's the one that actually worked with this idea of the barometer. And because of him, because he did so much good work there, then we have the same unit here. And so we say that 760 millimeters of mercury, we call that 760 torr. So whenever you see a torr as a measurement, that's really millimeters of mercury. Now, we want to go back here and do a little quick conversions, just some mathematical conversions. And first part of it is when we're talking about 14.7 pounds per square inch, a lot of times you're going to see that written as PSI. And PSI just means pounds per square inch. So here's a gauge, and that's measured in PSI. And a lot of times, you know, if you're doing your tires are in PSI. So a tire gauge, if you're checking the air pressure in your bicycle or your car, then, you know, the number you're talking about is PSI. On my car, it's about 35 PSI for the tires. On a bicycle, so smaller tires, they're really supposed to be somewhere around 100 PSI. So let's say we want to convert 45 PSI into atmospheres. So we just say 45 PSI, and we're going to make a conversion factor. And a conversion factor, all we have to do is pick the two numbers from our set of values to use as a conversion factor. So we know that there are 14.7 PSI in every 1 atmosphere. So the calculation is 45 divided by 14.7. We're going to see that that's going to be larger than 1 atmosphere. And in fact, when you calculate it, it comes out to be 3.06 atmospheres. Our second problem, let's say we had 98 kilopascals, and we want to change that into millimeters of mercury. And the reason we do this is that sometimes we have some measuring instruments that are going to give us values in kilopascals, other measuring instruments that would give it in millimeters of mercury, and if we want to be able to compare those values, we're going to need to convert. So I'd say 98.0 kilopascals. And again, we want to make a conversion, so kilopascals, here's our number, so that we'll put that in the denominator. And we are trying to get to millimeters of mercury, so we'll put that in the numerator. And the math is very simple. It's going to be 98 times 760 divided by 101.3. And when I did that, I can see my 98 over 101.3, that's a little bit less than 1. So I expect an answer a little less than 760. And in fact, when I calculate, I get 735 millimeters of mercury. And those are the skills you need to have for this chapter.